In the advanced separation technique, last chapter is chapter number 12, membrane or osmotic distillation, right? So first one, what is the membrane distillation? Membrane distillation is the thermally driven separation process in which only vapor molecule transfer through a microporous hydrophobic membrane, means non-wettable membrane. The driving force in the membrane distillation is the vapor pressure difference induced by the temperature difference across the hydrophobic membrane. This process has various applications like the desalination, wastewater treatment, and it in also the food industry. Now, what is the principle of the membrane distillation? The most process that use the membrane to separate the materials that rely on the static pressure difference, the driving force between the two bonding surfaces, just like the reverse osmosis also, and the difference in concentration like dialysis, right? Or say in electric field. The selectivity of the membrane can be due to the relation of the pore size to the size of the substance being retained on the membrane surface and its diffusion coefficient also, right? And or its electrical polarity based on the driving force. So membrane used for the membrane distillation inhibit the passage of the liquid water while allowing the permeability for the free water molecules and thus for the water vapor also. The driving force which delivers the vapors through the membrane in order to collect and the permeate side as a product water, and its partial water vapor pressure difference between the two bounding surfaces, means first upper side is for the hot water and above the membrane that is the cooling zone, right? This partial pressure difference is the result of the temperature difference between in the two bounding surfaces, when the upper side of the membrane and below the membrane, as can be seen in the image. Now membrane is charged with the hot feed flow on the one side and cooled permeate flow on the other side, as shown in the figure. Hot saline water feed is entering at the above the membrane and the cold stripping water that is entering below the membrane. Now this is the setup provided in the desalination of the water. This is the standard setup of the desalination of the water. The driving force which delivers the vapor through the membrane in order to collect it on the permeate side as a product water, right? So here that is shown in the figure. So the temperature difference through the membrane is usually between the 5 and 20 Kelvin, conveys the partial pressure difference which ensures that the vapor developing at the membrane surface follows the pressure drop also and permeating through the pores and condensing on the cooler side also, right? So generally temperature difference between the membrane, above the membrane and below the membrane, it is having a temperature difference about 5 to 20 Kelvin. Now mass transfer in the direct contact membrane distillation process includes the totally three steps. First, the hot feed vaporize from the liquid or gas interface. Secondly, the vapor is driven by the vapor pressure difference and crosses from the hot interface to the cold interface through the pores. And thirdly, the vapor condenses into the cold side stream. Therefore, there are two major factors that controls the membrane distillation mass transfer. First one is the vapor pressure difference and second one is the permeability of the membrane. If the fluid dynamics will include the fluid dynamics in the membrane distillation on the both side of the membrane could be considered good. Mass transfer through the membrane may be the limiting step for the mass transfer in the membrane distillation, and the influence of the physical properties like effective area of the mass transfer. Second is the membrane pores do not means membrane pores do not straight through the membrane and the path for the vapor transport is greater than the thickness of the membrane. And third one is the inside walls of the pores which relates with the resistance of the diffusion. right? These three are the physical properties related with the membrane distillation and its mass transfer. Now, the mass transfer phenomena, it includes total three basic mechanisms: Knudsen diffusion, molecular diffusion, and viscous flow. So, first one is Knudsen diffusion takes place when the pore size of the membrane is too small. Second, the molecular diffusion occurs when the molecules more corresponding to each other under the influence of the concentration gradients. And the viscous flow, it relates the gas molecules act as a continuous fluid driven by a pressure gradient, right? So these are the principles of the membrane distillation and its mass transfer. Now the membranes used for the membrane distillation and its application. So there are totally two types of the membrane configuration that is shown in the figure. First one is the hollow fiber membrane, second one is the flat sheet membrane. The hollow fiber membrane mainly prepared from the polypropylene. The second one is PVDF, means polyvinyl polyvinylidene fluoride. Third one is the PVDF included with the PTFE, means the polytetrafluoroethylene, right? And the flat sheet membrane mainly prepared from the PP, PTFE and PVDF. The most common materials used for the membrane distillation membranes are the PTFE, PP and PVDF that are commonly used in both hollow fiber and the flat sheet. Now the porosity of the membrane used in the range of 0.60 to 0.95 and the pore size in the range of 0.2 to 1 micrometer, and the thickness is in the range of the 0.04 to 0.25 mm. So first, if we consider the hollow fiber membrane, then the hollow fiber module, which has been used in the membrane distillation, has thousands of hollow fiber bundled and sealed inside the cell tube. The feed solution flows through the hollow fiber and the permeate is collected on the outside of the membrane fiber, or the feed solution flows from outside the hollow fiber and the permeate is collected inside the hollow fiber, outside or inside. There are two possibilities, right? And the main advantages of the hollow fiber module are very high packing density and low energy consumption. On the other hand, it has a high tendency to fouling and it is difficult to clean and maintain. So it is worth maintaining that if feed solution permeates the membrane pores is cell and tube modules, the whole module should be changed. Compared with the flat sheet membrane, hollow fiber membranes have a relatively large specific surface area, but the main impediment of the hollow fiber module is its typical low flux, right? It is having a 1 to 4 liter meter square per hour at 40 to 60 degrees Celsius flow flux. The low flux is related to its poor flow dynamics also and its resultant high degree of temperature polarization also. So will not use the flat sheet comparatively to the hollow fiber. And however, high flux hollow fiber membranes with different features suitable for membrane distillation have been developed recently, such as the dual layer hydrophilic or hydrophobic fibers with a very thin effective hydrophobic PVDF layer, which is having a thickness 50 micrometer, and hollow fiber membranes with a sponge like structure and thin walls also, which have a flux of around 50 to 70 at 80 to 90 degrees Celsius. This flux is high as that from flat sheet membrane, right? So if we consider the plate and frame, so it is having the packing density, which is the ratio of the membrane area to the packing volume, is very low, and the membrane support is required for the plate and frame membrane. If we consider the tubular membrane in this sort of module, this membrane is tube shaped and inserted between the two cylindrical chambers, hot and cold fluid chambers. In the commercial field, the tubular module is more attractive because it has a low tendency to falling, easy to clean, and has a high effective area. However, the packing density of this module is low and it has a high operating cost. The tubular membranes are also utilized in the membrane distillation. Tubular ceramic membranes were employed in three uh, membrane distillation configurations. Either it is direct contact membrane distillation, it is used. If it is air gas membrane distillation, it is used. It is vapor membrane distillation, tubular membrane can be used. To treat the NaCl aqueous solution also, where salt rejection was more than 99%. If we consider the spiral wound membrane, in this step the flat sheet membrane and spaces are enveloped and rolled around the perforated central collection tube. As you know the structure of the spiral wound membrane, the feed moves across the membrane surface is in an axial direction, while the permeate flows radially to the center and exits through the collection tube. The spiral membrane has good packing density, average tendency to falling, and acceptable energy consumption. That is the criteria for the membrane selection, right? Now, what are the typical applications of the membrane distillation? Typical application includes the seawater desalination, brackish water desalination, desalination of brine treatment, process water treatment, water purification, or removal or concentration of the ammonium resource concentration, right? So basically it includes all the desalination process and water purification process, right? So we ended here, and transcripts are also available on the Google Classroom also, and the slide share account, so you can follow, you can download the PDF also, right? Thank you.